This story begins in the year 2006, when leading scientists around the world detected a toxic gas in our atmosphere, methane. It was observed that methane levels had suddenly increased dramatically and were still continuing to rise. Methane is a type of natural gas that, when released into the atmosphere, traps heat near the Earth's surface. Just as we use a blanket in winter to keep warm, methane acts like a blanket around the planet, trapping heat inside and making the Earth warmer. Methane is even more powerful at trapping heat than carbon dioxide. When its levels began rising rapidly in 2006, scientists initially believed this was due to human-made pollution. However, further investigation revealed something shocking, a major secret hidden beneath the Earth's surface. The questions were, where was this methane coming from? Why was it increasing so rapidly? How do scientists detect methane? And most importantly, is this a sign of the end of the world or evidence of a massive climate shift? Welcome once again to Factify TV. The scientific community already knew that methane spikes in Earth's atmosphere typically occur once every 100,000 years. This knowledge comes from ice core samples drilled from icy regions such as Antarctica and Greenland. Every year, layers of ice trap tiny pockets of atmospheric air. Over thousands of years, these layers stack up, preserving a detailed record of Earth's past atmosphere, like a time machine frozen in ice. By analyzing these ice cores, scientists discovered that throughout Earth's history, methane levels spike roughly every 100,000 years. These spikes usually indicate the end of an ice age and the beginning of a warming phase. Once an ice age begins to end, within just 20 to 30 years, massive amounts of ice melt, and Earth's climate starts resembling what we experience today. The problem is that similar methane levels were last recorded 12,000 years ago, when the last ice age ended. So why are methane levels rising again so soon? Is Earth heading toward another major transition, or is this an entirely new danger? To understand this mystery, we must look at Earth's geological history. We are currently living in the Quaternary period, which began about 2.5 million years ago and continues today. This period is divided into two phases. The first was the Pleistocene epoch, lasting until about 12,000 years ago, during which Earth repeatedly entered and exited ice ages. Massive ice sheets covered large portions of the planet, melted, then returned again in cycles. This era also saw the rise of early humans and the extinction of giant animals like the mammoth. The second phase is the Holocene epoch, which began 12,000 years ago and continues today. During this time, ice retreated, the climate stabilized, and temperatures warmed. This allowed humans to develop agriculture, settle near freshwater sources created by melting glaciers, and build civilizations. Technically, however, we are still in an ice age, because ice still exists at Earth's poles. An ice age truly ends only when no permanent ice remains on the planet. The glaciers today are simply smaller than they were at the ice age's peak. What causes ice ages to end? Scientists have identified three major factors known as the Milankovitch cycles. The first is eccentricity, which refers to changes in Earth's orbit around the Sun. Sometimes the orbit becomes more oval-shaped, bringing Earth closer to the Sun and increasing heat. This cycle lasts about 100,000 years. The second factor is axial tilt. Earth is tilted at approximately 23.5 degrees, but this angle changes over time between 22.1 and 24.5 degrees in a cycle lasting 41,000 years. Greater tilt results in warmer summers at the poles, causing faster ice melt. The third factor is precession, the slow wobble of Earth's axis, similar to a spinning top. This affects seasonal timing and operates in cycles of 19,000 to 23,000 years. Together, these three cycles gradually warm the planet. Ice melts. Darker land and ocean surfaces are exposed. Dark colors absorb more sunlight than reflective white ice, leading to further warming and continued ice melt, a self-reinforcing cycle. Earth warms even more when trapped greenhouse gases, such as carbon dioxide and methane, are released from oceans and frozen ground known as permafrost. These gases accelerate warming. Why did methane levels spike again in 2006? Even though the ice age ended 12,000 years ago, human activity from the growing natural gas industry increased methane emissions in the 20th century, but those emissions stabilized by the 1990s. So where did the new spike come from? Methane is released not only by humans, but also naturally from underground reserves, wetlands, oceans, and frozen permafrost. With modern satellite technology, scientists can detect methane by sending laser beams of specific wavelengths toward Earth. Methane absorbs this light, allowing scientists to map its sources globally. Using this technology, NASA identified a 3-mile-long methane cloud over a landfill in Iran, releasing 73,440 tons of methane per year, equivalent to the weight of 180 jumbo jets. Even larger emissions were detected in Turkmenistan, where oil and gas sites release hundreds of kilograms of methane every hour. However, scientists believe these sources explain less than half of the methane spike since 2006. A major portion is being released from forests that once sat atop permafrost. As permafrost melts, ancient organic material decomposes rapidly, releasing methane into the atmosphere. The biggest challenge with methane is that once it escapes into the atmosphere, it is extremely difficult to capture, especially in forests. While methane can be collected from landfills and gas fields for energy production, forest emissions cannot be controlled. Methane remains in the atmosphere for about 10 years, after which it breaks down into carbon dioxide and water vapor. The concern is that while methane spikes occurred naturally 12,000 years ago, they happened during Ice Age transitions. Today, glaciers have already melted significantly, yet methane levels are rising in ways never seen before. This may indicate that Earth is entering an entirely new climatic phase. At present, scientists cannot confidently predict whether Earth is heading toward the complete end of the Ice Age or toward another one. There is no historical reference showing methane levels rising this dramatically after 12,000 years. We also don't know how high these levels will go, and if this process is natural rather than human-driven. It may be impossible to stop. We hope you enjoyed this episode from Factify TV. Please like, share, and leave your valuable comments. Thank you for your continued support, and we'll see you in the next amazing video.